Let's learn about rational exponents. Number 5 says, come on, be rational. Pi says, I can't, this is who I am. On our agenda, we're going to look at going back and forth between exponential and radical forms. We'll talk about negative exponents, and we'll go through the rules of exponents with rational exponents. Let's get ready. You're going to need to grab your notes and pencil. And what even does rational exponents mean? Well, if something's rational, it means it could be written as a fraction. So we're going to be looking at something like x to the 2/3 or 8 to the 2/3. So we're going to have fractional exponents. So we need to become familiar with the different forms. This is an exponent. If I have x to the 1/5, that denominator becomes my index. So that 5 is going to get tucked into that radical bar, and I have the 5th root of x. So x to the 1/5 is the same thing as the 5th root of x. The square root of x is the same thing as x to the 1/2. So you need to be familiar and be able to go back and forth with those two forms, especially as we move into exponents and then logarithms. So here we have it using our letter format. The index in the radical form becomes the denominator of the exponent. So let's rewrite this in exponential form. This is in radical form. So it's 16 to the 4th root of 16 becomes 16 to the 1/4. Sometimes it's easier for kids to see the answer in this form. It's 2. Sometimes it's easier to see it in this form. It's also 2. Negative exponents. You've worked with negative exponents before. Remember, negative exponents does not make the number itself negative. It just means reciprocal. So whenever you have something that's in the numerator with a negative exponent, it's going to go down to the denominator. It's going to be the reciprocal. If I had 1 over x to the negative a and it was negative in the denominator, then I'm going to apply the reciprocal, and it's going to become x to the a. Never leave negative exponents. You're not finished. Make sure you move them across that fraction bar. Here we have the example of x to the -2, negative exponent, so I'm going to do the reciprocal, and this becomes 1 over x squared. A power raised to a power means that you're going to multiply the exponents. So here I have an exponent, parentheses raised to an exponent, and I'm just going to multiply. So in this example, I have 2 cubed squared, then becomes 2 to the 6th. Let's think about it now with fractional exponents. So if I have 8 to the 2/3, there's a couple different ways I could write that. The way that I prefer is to pull the denominator in, which we now know is the index. So I'm going to think of this as 8 to the 1/3 squared. It's the same thing because remember it means multiplication. 1/3 times 2 is 2/3. But I like to go smaller first, and by taking the denominator in, I'm then doing a root to it. So 8 to the 1/3 is 2, 2 squared is 4. You could separate it the other way. You could write it as 8 squared and then take the cube root. But then you're going bigger. You're going up to 64, and maybe you know the cube root of 64 is 4. But I like to make things smaller as I'm simplifying. So go ahead and pause and try this one. And keep in mind, we don't have any parentheses, so this negative is going to really just be the opposite. It's going to be applied after. So I have negative 125. I'm going to pull in my denominator and then square it. So the cube root of 125 is 5 squared. I'm going to apply my exponent, so I have negative 25. Multiplying rules for exponents means when you have the same base and you're multiplying, you add your exponents. So here we have our fractional exponents. Remember, when you're adding fractions, you have to get a common denominator. So this would become 12 and then a common denominator of 6. So 3 6 and 12 and 6 and 4 6 is 12 and 7 6. When you're dividing, you're subtracting the exponents. So again, if they're fractions, you're going to have to get a common denominator. So here we have 125 to the 4/6, 100 over 125 to the 1/3. Get a common denominator. I could just simplify that one, go that way. That would be a little bit easier. And then I'm doing 2/3 minus 1/3, so I get 125 to the 1/3. If it's something that you know, then you should continue simplifying to 5. A power to a power. We're multiplying the exponents. We saw this, we talked about this a little bit earlier, but I just want you to remember that 2/3 times 3 is really 3 over 1, which is going to be 6 over 3, which is 2. Do not do 2/3 times 3 and 3 and then call it 6/9. That's wrong. You don't multiply the 3 into the numerator and the denominator. It's 3 over 1. So then this becomes 8 squared, which is 64. A product to a power. Product means multiplying, so I'm multiplying here, and then I'm raising it to a power, means that I can distribute that, and everything inside needs to get that exponent. Please note that this is different than addition raised to a power. You cannot distribute. No, don't do that. So here we have our example, 16 times 25 raised to the 1/2. The 1/2 can go into both. And if we remember what 1/2 means, it means the square root, because that is 2 index. So that becomes 4 times 5, and it simplifies to 20. Quotient of a product. Quotient is division raised to an exponent, so that has to go to the top and the bottom. Sometimes kids forget to put it in the bottom, so remember that. Here we have our example, 16/81 raised to the 1/4. I can distribute that 1/4 to the numerator and the denominator and take the 4th root of each, and it becomes 2 over 3. Here's a challenge for you. You can see I have a fraction. It's negative. So let's think about that. If it's a negative fraction, the first thing I'm going to want to do is do the reciprocal. So I get 1 over 7/8. You may be tempted to think about that as 8 and then w to the 7th, and that is a correct thing. That's a radical form. But now we can see that we have a radical in the denominator, and we don't want to have that there. So we have to rationalize this. I think it's easier to think about it in fraction form. And basically, I want to get a whole w in the denominator. So I want to get just w, which is w to the 1, which is w to the 8/8. So I need to multiply top and bottom by w to the 1/8. Because remember, when I'm multiplying, I'm adding my exponent, so I'm going to end up with w to the 1/8 over w. Let's recap. The index becomes the denominator of the exponent. Negative exponent means reciprocal, not a negative number. Power raised to a power, you're going to multiply. When you're multiplying, you're going to add your exponents. When you're dividing, you're going to subtract. And then you can distribute if you have a product or a quotient. Nice work.